Alright, if you guys could please turn to the page in your notes, it looks like this. 1.3, use midpoint and distance formulas. Alright, a midpoint is a point that divides a segment into two congruent segments. It divides a segment exactly in half. Just a reminder, this little symbol here means congruent. So for example, if you have a segment, we always use AB. Let's use XY. And you have a point M, it right smack dab in the middle, and these two segments are congruent, that point is the midpoint. These little dashes indicate that this segment is congruent to this segment. Okay, you'll see those things a lot more. A segment bisector is pretty much the same thing, except that it doesn't have to be a point. It could be a point, or a ray, or a line segment, or even a plane. Okay? Alright, so for example, here we're supposed to find RS. Remember, this little dash means that this is the exact same length as this. We know that T is the midpoint of RS. So RT equals TS. So if this is 21.7, this is also going to be 21.7. Both of them equal 21.7. Alright? Now, I know that RS is RT plus TS. Once again, that's the segment addition postulate. I'm going to substitute the values that I'm given in the diagram. And then I'm going to add 7 plus 7, that's 14. Carry the 1. That'll be 3. 43.4. Okay? So the length of RS is 43.4. Okay? Alright, checkpoint. I'd like you guys to try this one on your own. Okay? Let's go on to page 2. Point C is the midpoint of BD. Find the length of BC. Alright, now we know that BC equals CD. Okay, so we have this equation. BC is 3x minus 2. And CD is 2x plus 3. Okay? I'm going to subtract 2x from both sides, just to start things off. Oops. Okay, so I've got x over here. On this side, the 2x cancels out. Now, I'm going to add 2 to both sides. So over here, the 2's cancel out. 3 plus 2 is 5. I added 2 to both sides. So, we know that x equals 5. But that's not what we're looking for. We're looking for the length of BC. BC is 3x minus 2. So if I plug in 5 for x, I'm going to get 3 times 5 plus 2. I'm sorry, minus 2. 3 times 5 is 15. 15 minus 2 is 13. So the length of BC is 13. Alright, this one's very similar. You can pause the video here and try it. Okay? Make sure you guys actually do these checkpoint problems because I do grade them. Alright, the midpoint formula. This is a good thing to memorize. We're going to be using it a lot, so it should become pretty familiar. But it's a good thing for you guys to know. Okay? Basically, if you are looking for the midpoint between 2 points, you add the x's and divide by 2, and then you add the y's and divide by 2. So for example, if we are trying to find the midpoint between negative 2, 5 and 4, 3, this is how we do it. The x coordinates are negative 2 and 4. So add them together and divide by 2. The y coordinates are 5 and 3. So add them together and divide by 2. Negative 2 plus 4 is positive 2. Positive 2 divided by 2 is 1. 5 plus 3 is 8. 8 divided by 2 is 4. So the coordinates of the midpoint are 1, 4. Okay. Now the second one says the midpoint of AC is 3, 4. It's not given on the diagram. One endpoint is 1, 6. Find the coordinates of endpoint C. So in this case, we kind of have to work backwards. We're given the midpoint. We already know what the midpoint is. The midpoint is 3, 4. So the x is going to be 3 and the y is going to be 4. Okay? One endpoint is 1, 6. We need to find an x value and a y value that will give us 3 and 4. Let's solve for them one at a time. Over here, if I multiply both sides by 2, that'll get rid of the 2 on the bottom. So now I have 1 plus x equals 6. Now I can subtract 1 from both sides. 6 minus 1 is 5. Same thing over here. 6 plus y equals 8. Then subtract 6 from both sides. Y equals 2. So the coordinates of endpoint C are 5, 2. Okay, so if you're given 2 endpoints and asked to find the midpoint, this is what you want to do. If you're given an endpoint and a midpoint, this is how you want to go about solving for it. Okay? Alright, another checkpoint. I'll let you guys pause here and try this one. Last page. The distance formula. Okay, this is another good thing for you guys to memorize. Okay, AB is x2 minus x1 squared plus y2 minus y1 squared. Okay, so let's do an example. What is the approximate length of RT with endpoints 3, 2 and negative 4, 3? Basically, just plug them in. It doesn't matter which one you make your x1, y1, x2, y2. I'm just going to do it like this. This is x1, y1. This is x2, y2. Alright. The distance formula, once again, x2 minus x1 squared plus y2 minus y1 squared, square root. x2 is negative 4. y2 is 3 and y1 is 2. I just plugged in these numbers into this equation. Negative 4 minus 3 is negative 7. 3 minus 2 is 1. Okay? Negative 7 squared is positive 49. 1 squared is 1. 49 plus 1 is 50. Okay? Now, generally speaking, you can just leave your answer like this, unless it says to round to a particular decimal point. Okay, so let me pull out a calculator. 50 square root 7.07. I'm going to round to 2 decimal places. This little squiggly equal sign means approximately. Okay, so it's not exactly equal to this because I rounded, but it's about 7.7. So the length of segment RT is about 7.07. Alright, and this is the last checkpoint. I'll let you guys do this one on your own. And that's all.